Hello everyone. Just a brief recap or breakdown of what correction Dr. Nobila gave to us in class yesterday. So first thing first, he mentioned that you have to draw with pencil. It would have ended you. Excuse me. So I've handed you one mark. We did draw your table with not the table now. If we did draw your chart with a pencil one mark, with a ruler one mark. Also, if you have included a chart title, that's also one mark. And here I'm just showing a brief or way I do write my chart title. So here showing that mean longevity against diet type by gender. Okay, maybe I didn't draw the chart. I didn't draw the bar chart the way you drew it on the board, but I believe we can understand. So to understand it better, I think we'll look deeper into it. I think that's what the discussion is all about. And first thing first, I think we've covered chapter two. We'll just look at the mean. So and this will start by we analyzing the axis. Y axis meaning the horizontal. Beg your pardon. The vertical axis is showing us. Vertical axis is showing us okay, I'm trying to use a pen. It's showing us the longevity, whereas here the x-axis is showing us the gender and the diet. And one other thing that is also in this graph or in this chart is that you have letters written on the bars, and those letters are what we call the homogeneity of mean. Letters that have or bars that have the same letters have no significant difference, whereas those who have different letters have significant difference. So for example, B and B have the same letters, that's male sucrose and male water. They have the same letters, meaning there is no significant difference in the p-value or in our interpretation or in the diet, but we're supposed to combine all these things together. So but those who have different letters A and B, there is significant difference. How, what does that mean? We would look at that when we are comparing, or how would you write it rather? We'll look at that. Okay, let's just look at that right now. So to these things are what we call variables, and we are comparing variables. And according to him, if we are comparing this set of variables, we are supposed to get 28 comparisons. Why is that? We'll just talk about everything in a go. So here we have male sucrose, male. We have, let's say we have male group and female group. So let's say, just so that we don't just go all around the table, let's pick it group by group first so that our work can be structured. Let's say we are doing group one, that means we are doing male group. We compare everything inside the group. We do female group, we do everything inside the group. I'm very sure when you do another, you see something like within the group and outside the group. So after that, we now compare outside the group, meaning we compare male sucrose to female sucrose. So how do we compare within the group, and how many number of comparisons will we get? Comparing within the groups, or okay, let's say we are comparing male and male sucrose to male host fluid. Now, what are we comparing? Firstly, we're comparing their mean. This is 6. The other one is 4.1, meaning male host fluid is more the mean longevity. We live longer than the male sucrose, meaning males who are fed host fluid live longer than male who are fed sucrose or 10% sucrose. That's the word. So how do we write this? I think I have a sample here. Okay, so the sample is just saying male host fluid versus lived 1.9 days longer than male sucrose or 10% male sucrose. These two groups belong to different homogeneity group. That's C and B, meaning there is a significant difference because they have different letters, they have different homogeneity group. And how do we get homogeneity? For those of us that can remember in her ANOVA under post, or for example, if you pick two key, they fall under the same column, under the same group. If they have the same, if they have no significant difference, they will fall under the same column, or they will fall under the same group of homogeneity. But then if they have different, beg your pardon, if they have no significant difference, they will have different groups under homogeneity post hoc. So for example, I'm just saying that so that in case we are doing the chart ourselves and it's not written on the bar chart. And let's look at the other example here. I'm just giving us a sample of how we can write our samples. So another example I think I have there is the female let's look at it together. So we have, yeah, okay, we have female water outlived female sucrose by 2.2, and it's just up to you how you write it. It's not compulsory that you write it this way. You can write female water lives longer than female sucrose, and they have no significant difference. Why? Because they have C in common in their homogeneity. And you don't even have to put the because, they can just write it very short. Female water lives longer than female sucrose, and they have no significant difference. We move to the next line. It just depends on how detailed you want to make it. So I just had to make this PowerPoint as fast as I can, so a lot of things might not be as detailed as the whole paper, or the whole test score, or the whole test script. So one other thing we want to consider is the fact that we are comparing male sucrose to male host fluid. That's one. We are comparing male sucrose to male water. That's two. Male sucrose to male starch. That's three. We have three. And there's something called permutation. In permutation is a way of knowing how many results you are supposed to get from a total number of, if you are comparing a total number of things together. So we have four total number of groups here, or of mean bars here. The formula is n minus 1. That's 4 minus 1 times 2. Now if we have 5, that will be 5 minus 1 times 2, right? Now that means that we have 6 here. Let's check it together. 6, we have male sucrose times, well, male sucrose versus male host fluid, that's 1. By the time you do male sucrose versus this 3, that will give it 3, right? But you would not be going back when you are coming to host fluid. You will not do male host fluid versus sucrose again, because you already done sucrose versus host fluid. It will give you the same result. So we don't do that again in comparison. If not, you keep going in circles. So that's 3. We will now do male host fluid versus male water and male starch. That will give us 2, right? Then plus male water versus male starch, that's give us 1, give us 6. So if you have 6 here, that's within the group. You have another 6 here in female, that give us 12, right? So let's compare outside the group. When we are comparing outside the group, we now have male sucrose versus these 4. That's 1, 2, 3, 4. You compare one by one. Male sucrose versus female sucrose, male sucrose versus host fluid. That give us 4. Now you do the same thing for host fluid versus this 4. That give us another 4. Do the same thing for water versus this 4. That give us another 4. Give male starch versus this 4 again. Give us another 4. That give us 16, right? So if we compare this 16 plus the 12 we had initially, that give us 28 in total. So in short, you're supposed to have 28, and if you use your permutation also, you get the number of, you understand that you get the total number of comparison in initially, or according with the formula. Okay, so let's quickly go to the summary. Let's quickly go to the summary from here. I think that's the last thing I don't know if I have covered everything, but I think that's the only thing. So for the summary, in summary, I'm just okay. Sorry, this summary. Summary, I'm just saying across the 28 pairs, or your summary can include maybe what happened in the chat. I'm just using this as a sample, but according to your discussion, your summary should not be more than this. Like it can be more than this. You can even I can write beg your pardon. You can write a summary that can be 2 pages, but you can. It depends on how much time you have. Across the 2 pages, firstly, it shows the chart shows that diet has the highest influence. It has influence more than gender. Remember that on our x-axis we had both diet and gender, meaning meaning there are two factors we are considering, but it's still one way and over we use. Why? Because those factors are subsets. So now in the two factors, the diet has more influence, because when you compare host fluid of male and female, they are both high. Meaning, for example, if host fluid in female has been very low and has been high, we say the gender has more power, has more capacity to influence the longevity than the diet. But they are both high, meaning diet has higher capacity. But then when you now look closer, when you now zoom in, you now notice that, oh, even under the diet, the gender is showing us a variability, meaning our female live longer than our male, even when we consider the diets that we are using. So both are still under diet, both are still different in the sense that female will live longer, but then the diet influences the longevity more than the female. And under the diet, we say that host fluid produces longest lifespan, starved produces shortest lifespan, things like that. And then you can make it pointers, point one, point two, point three, point four. But you're discussing, so you just want to be very very fluid with your word. So I think this covers everything. Thank you, everyone.